and welcome to another video. Today it's Advent of Code. It's that time of year again, and I really want to see your solutions, so leave those in the comment section down below. If you want to support the channel, there is a link in the description to different affiliates where you can get great deals on things, and there's also a donation link if you want to donate a coffee to me in order to improve the quality of the channel. Day 10. Hoof it! All arrive at the lava production facility on a floating island in the sky. As the others begin the search for the massive industrial complex, you feel a small nose boop your leg, and you look down to discover a reindeer wearing a hard hat. The reindeer is holding a book titled Lava Island Hiking Guide. However, when you open the book, you discover it mostly seems to have been scorched by lava. As you are about to ask how you can help, the reindeer brings you to a blank topographic map of the surrounding area. Your puzzle input. It looks up at you excitingly. Perhaps you can fill in the missing hiking trails. The topographic map indicates the height of each position on each position using a scale from 0 to 9, lowest to highest, for example. Based on the unscored scraps of the book, you determine a good hiking trail is as long as possible and as even, gradually uphill slope. For all practical purposes, this means that the hiking trail is a path that starts at 0, ends at 9, and always increases by a height of exactly 1 on each step. Hiking trails never include diagonal steps, only up, down, left, or right for perspective of the map. You look up from the map and notice that the reindeer has helpfully begun construct a small pile of pencils, markers, rulers, compasses, stickers, and other equipment you might need to update the map with hiking trails. A trailhead is a position that starts on one or more hiking trails. These positions always have the height 0. Assembling more fragments of pages, you establish that trailhead's score is number of 9, position reachable from the trailhead via the trailhead. In the above example, a single trailhead, top left, has the score of 1 because it can reach a single 9. This has 2, and then we have something with 4 and so on, and the last one here, which is the thing that I will run an example on, has a trailhead score of 36. The reindeer gleefully carries over a protractor and adds it to the pile. What is the sum for the score of all trailheads on your topographic map? And this is the map. It's huge. So let's see. True. Let's run the test. It's number 10. So now we're going to go through each line. We're going to split it up. We're going to create this big map. So lines, size. This is our height. And then we have width, which is lines, get 0, length. So now we have a width and a height. We for loop over a string, line of lines, like that. We will create a map of the integers, new integers, width times height, like that. And then for each line we will take out each character. Feels like we've done this a million times now. Line, split, nothing, that. And then int I plus plus For each character we take the... Whoop. We want this to be before here, of course. So that's the assignment. We take map I and add integer parse int character. Any line that is blank, we will continue on. So we just skip those, and we can also trim so we don't have any extra spaces around it. Now we should have the map. So now we need to go through each of these. We use J, 0, and J. Now we want to take Y to height, Y++, and then we do a for loop for X width like that, and then we will if int count here, like long, if it becomes a lot. Count plus equals to count trails, and we have a map X and Y, and then down here we take count and print that. So let's count the trails. And we also want to have 0 as the value. Val. So if val or map y times height, no, width plus x is not equal to val, then we return 0. So that's it. Shall we add width here as well? Can do like that. So now we count trails. If val is equal to 9, then return 1. And then we have an internal count here, which is 0. And that is what we will return. And then count plus equals to map x plus 1 y with val plus 1. Or yeah, val plus 1. That is the easiest to figure. Let's see here. We have 4 directions, right? So we have x plus 1 minus, and then x stays the same, but y will go plus 1 minus 1. So now I don't go to any other directions, we just go through those. Let's see. Count trails. Out of bounds for length. Okay. X less or equals to width. Yeah, we can need to have the height as well. could have these as some kind of static values if we want. I think it's just fine to add them here, like that. So if that, then return 0. If y is larger or equals to height, if x is smaller or equal to 0. Let's see, if, yeah. And here we need to have -1 because we can't go all the way. Y. Like that. What? Oh, yeah. That was stupid. We get 8, which is more than 0. Yeah. We need to do those checks first. 55. And that's more than 36. Each of the numbers needs to have one value, right? So here we will return a set of points. And we can use day 8's point class, because I don't think that was that more complicated. It has a character, we don't really care about the character. But other than that, it will check so we don't get any duplicates or anything like that. So I think that's fine. List or set size count plus equals. So that's what we do. And here we do set point new set hash it, new hash it, like that, and then we will new set add all to the s, and this will return a set as well. Like that, and this will return new set. So what we're doing now is trying to get all the unique points we can end up in. New hash set. So here we will always just return nothing, no extra numbers. And in this case, we will have a little bit more code. We will have a new hash set, return that new hash set, and this we want to take new hash set, add new point, and this should be 9x, y. So now we get 20 points. I wonder if we just remove that. If we go closer, 36. So it's just a bounding error. So now we are picking up on all the unique trail points that ends up in the right position using a set. And we get 496 from the large one. Let's put that in. Yes, you get a gold star. I get a gold star. Everybody gets a gold star. So let's look at part 2. The reindeer spends a few minutes reviewing your hiking trail before realizing something, disappearing for a few minutes and finally returning with another set of slightly scarred pieces of paper. The paper describes a second way of measuring a trailhead called a rating. A trailhead's rating is the number of distinct trails which begin at that trailhead, for instance. And a single trailhead rating is 3 because there are exactly 3 distinct hiking trails which begin at that position. Okay. Ending up in the same... Okay. The map containing a single trailhead rating is 13, this map. Because there are 121 distinct hiking trails that lead to the 9 bits of paper, using them to mark the trailheads on your topographical map. What is the sum of the ratings of all the trailheads? So now we need to add more to this point. Which means that we need to have our own point. And this one will have private final int rating instead. And the rating will just be int rating. Then we remove the anti-point. We can remove x and y. We have the equals and a hash code left. We will add a function here to get the rating. We will also have a function public void inc rating plus plus. Yeah, so we need to remove the character from this operation, of course. And we had another anti-points here. Okay, so now we are more in line again. So what I want to do now is in day B, we will use our own point instead. And here we will set a rating of 1. And when we get trailheads back, point first, or we can call it res1. We want to go through this, get each point in this res, and if new set contains this, p, then p plus plus, p inc rating. So that's what we want to do for each and every one of these. And it should be the same object, so we don't need to do any extra work here. New set, add p. Like that. Else. You can even have an else statement. So if it doesn't contain it, then add it. I wonder if you need to do res1 get. I wonder if the better way of doing this is actually using map. Let's try that. Map integer. Then for map entry point integer entry, call that res instead, and then we do count plus equals to entry get value, and then we just need to return this one, return a hash map, like that. So let's see. So now we need to have a point, integer, and here we put a point of 1. Now we do the same. Then we just do like res key set p new set contains key of p. In that case, new set get p new set put p plus 1. Otherwise, if it doesn't contain, then just get that value. I'm not even sure if this is correct. It's less wrong at least. Let's see here. What do we get? Do you expect something else? How is this even possible? If we get a p-value that is contained in the set. And it should be null, right? Let's see here. Yeah, okay, so res get p. That's what we want to do. And here we don't want to do that, we want to do that. A little bit of a difference, but still. That's not correct. 81 should be the right one. Are we doing it on the... No, we're not doing it on test. That could be it. If we do it on the test, we get 81. If we do it on the full set, we get 1020. Yes, you get a gold star. I get a gold star. Everybody gets a gold star. So we had done the right solution. I actually just wrote a bunch of code and then it solved itself. So what we did here is created a length and height. We created a map. We went through and filled this map with all the numbers. So now we needed to figure out how many different trailheads or different routes could get to the same trailhead. We did this by keeping track of a point and the number of ways to get to that point. And this is the map that we have here. And the result is walking the trailheads and getting the number. Pretty much. So we will go through this entry set, get the value, and add to our count. The count trails works very simply here by first checking, are we out of bounds of the map? Pretty much. If we do that, return an empty hash set, so we don't add any new points. If the value that we are ending up in is not the correct value, because we are starting at 0, then going to 1, 2, 3, and so on. If we end up in an incorrect value, then return an empty hash map. We will not continue on that trail. Then if the value is 9, we want to stop here and start calculating trailheads pretty much. So now we will create a new hash map. We will add in a new point and say that this point here, we have at least one trailhead that ends up here. And then we return that new set. And then we will go through each of these different directions. And we iteratively go down in these directions and add to the value with 1. And then when we go in this x plus 1 direction to the right, we will get a number of these where we added 1. So in some cases when we go right, we get a 1. But we don't know if this is the only trailhead or the only route there. So we will check through our list here of results, and we will check the new set that we have and see if it contains any of these. Then we will add up the current int value with the result int value. So we will add both sides. So get all the trailheads that could end up here. If not, we will just take the result value and add that. And then we will do that for all 4 directions. So it's a bunch of copy-paste code here. Could have made a function of it if we want, but I didn't. And then we will return this new set. So it's a little bit of a complicated thing. It's a bit of code, but I think at least it explains itself a little bit. So one thing, of course, we can do, we can take this here and extract the method. We can call this check direction like that. I'm not sure if, yeah, we can do that, and then we'll get the right. So if we do like that, and we do +1 here. If we now remove all these, add a couple of these, we do -1, +1, -1, just to see if this works. Yeah, so this will get the same result. So now we have a little bit more tidy code. We have moved it over to a function, so it's easier to see that this is the same implementation, the same thing that we do 4 times in different directions. I hope that you found this interesting. I hope that you learned something today. I would love to see your solutions. Leave those in the comment section down below. If you haven't subscribed yet, please do that. If you like this video, give it a like, share it with your friends and colleagues, and I really hope to see you in the next video.